Let's take a look at problem 5 on the practice exam. So, this one has a story. It says a window has the shape of a square surmounted by a semicircle. The base of the window is, okay, so blah blah blah. Let's come back to that in a second. Let's just make sure that we have an idea of the kind of thing that they're talking about. So, I checked on the internet, and this kind of thing is called a Norman window. So you've seen one before, I'm sure. So this is supposed to be the square, and now on top of the square is a semicircle that has the same, or the diameter of the semicircle on top is just the one side of the square, okay? Alright, so let's label some things. So let's call this x. So, so x determines everything, right? X determines everything about this diagram because we know that the box is a square, and then the semicircle just depends on the side of the box. So there's really only one variable. All right. So let's go and read some more of the question. It says, the base of the window is measured as having width 60 centimeters with a possible error in measurement of a tenth of a centimeter. Use differentials to estimate the maximum error possible in computing the area of the window. Okay, so remember, we did this in class, so you need the formula for the differential is dy, and that's equal to f prime of x times dx. Okay, and so the idea here is this tells you really, this x here is some fixed amount. So for us, this x is going to end up being 60. Okay, and so what dy here is going to tell us is how the area of the structure is changing if we increase x a little bit when x is 60. So maybe that's kind of hard to understand. So let me draw the picture again. So here's the box. Whoa, and it thinks it's a circle. So can I draw a box? Those are sharp corners, computer. Okay, alright, so there's the Norman window again, and now I'm just going to write 60, okay? So what dy means is, dy in this case will be how the area changes if when the window is size 60, we increase it by just a little bit, like 1/100th of a centimeter. So if we wiggle the width by 1/100th of a centimeter, or sorry, 1/10th of a centimeter, what does that do to the area? So that's what dy is. So in fact, alright, okay. So I use dy because dy is the familiar notation, but really what we're talking about is area. Okay, so the first thing that we need to do is figure out an equation for the area of the window. So the area of the window is equal to, let's see, so it's just going to be the square part plus the semicircle part. Okay, so how do I say that? So it's going to be x squared plus, and now, okay, so remember the formula for the area of a circle is pi r squared, but we only have half a circle, so it's going to be 1/2. And there's going to be a pi. Okay, and now I write r, which is x over 2 squared. Okay, alright, so notice that I wrote everything in terms of x. I didn't write 60 anywhere. That's because we want to know how y changes as x changes. If I just write 60, then I can't wiggle that, right? Because that's just a number. I want the variable around until the very end. So that's a common mistake according to the book anyway, with this type of thing, is to plug in a particular value too soon. We're just working with the variable, so this is the equation. All right. So now let's translate the formula for differentials into this situation. So what we're looking for is how the area changes, dA, when we wiggle x a little bit, And so the formula is, it says dA dx. Okay, so that is just the derivative of this stuff with respect to x times dx. Okay, so remember dx is the little bit by which you wiggle x. So in this case dx is 1/10 of a centimeter, so it's 0.1 centimeters. Okay, alright. So all we have to do is we have to figure out dA dx, and then we have to plug in x equals 60. So let's just do it step by step, okay? We've actually gone further in part A than we were supposed to. So in part A, all we're supposed to do is give an equation for the window, area of the window, which we've already done. It's that equation right there in red. Now we're going to go on to compute the differential and solve the problem, the second part. Okay, so this is the main thing that I need right now. So what is the derivative of the area with respect to x? So dA dx. It's a very simple thing to take the derivative of. It is 2x plus, and I guess I have to use the chain rule here. So this 1/2 pi is still there, 1/2 pi. And now the 2 comes down, and I still have x over 2. But now the chain rule tells me that I have to put in another 1/2. Alright, okay, so I can probably write this all in a nicer way. So what does this turn out to be? This is 2x plus, now this 1/2 and this 2 can cancel, and after that I get pi x over 4. And I can even write that in a better way. This is equal to x times 2 plus pi over 4. Okay, so let's leave it like that. And so that is the first thing. Alright, so now I can actually write out what dA is. So dA is equal to x 2 plus pi over 4. Oh, this dumb thing. Pi over 4 times dx. Okay, so now we found, this is the differential. And I'm sorry my handwriting is so bad. Okay, so we found the differential. Now all we have to do is we have to look at the differential when x is equal to 60. Okay, because we're looking at the case where the window has side length 60 centimeters and dx is 0.1. Okay, so when the window is 60 centimeters on a side and we wiggle it by 0.1, how does the area change? Alright, so all we have to do is plug in the values. So dA is equal to 60 times 2 plus pi over 4 times 0.1. Okay, and so what number is that? I think I'm in real life here outside of computer world. I'm fumbling through my notes. This turns out to be 16.71. Alright. Okay, so the units here are centimeters squared. So that's kind of interesting. If you have a window like this and the side is 60 and you jiggle the width of the square a little bit, then you end up jiggling the area by 16.71 centimeters squared. And that's the end of the question.